So many people try to do testing of the hydrogen concentration, which is of course important because there are a lot of products out there that don't make even detectable levels of molecular hydrogen. And the most simple way to test is using this reagent, the H2Blue, and it's more of an art than it is a science. The way that this works really is that you have this reagent and it has methylene blue in it, and it's going to react with the hydrogen molecules, and it's going to convert the methylene blue into leucomethylene blue, which is a translucent or clear form. And every drop of reagent you put into the hydrogen water that turns clear, it's equivalent to 0.1 milligrams per liter. So we continue adding drops stepwise until you reach what's called the titration endpoint, which is when you add the last drop of a reagent and it turns blue and it stays blue. That you count that many drops, and so if you added, say, 5 drops, then that's 0.5 milligrams per liter. Now, a lot of people will try to use this reagent and they add it correctly, but they don't use it correctly. And I'm going to show you a demonstration of how to use it correctly and not correctly. We just barely made some hydrogen water. I'm guessing the concentration is around 0.7 to 0.8 milligram per liter or so. And we're going to open it. Now, as soon as I open this bottle, immediately the gas starts, doesn't just immediately come out, but it starts to come out, okay? So we want to be quickly. We don't want to just sit here and talk for a long time without testing because the concentration is going to be lower. That's what I'm doing right now. You don't want to do that. You want to immediately test. So I'm teaching you what not to do. Now we're going to take this beaker. Now, there's these beakers, and actually they come with different ones. So this one right here comes with a specific beaker. I actually have it right here. It comes with this specific beaker, and you would want to use this very specific beaker in order to do the testing. Now I'm using these two because we want to do a comparison when you do the right way and the wrong way, just for comparison's sakes. So again, we shouldn't be talking this long because all the gas is coming out, and then you're going to get a lower reading than you should have got and then wonder why the bottle isn't working. But again, the point of this demonstration is to show you the wrong ways how to do it as well as the right ways. Now when you have the beaker, you want to make sure you put in 6 milliliters of water, okay? Now, this has graduation marks on it, but if you accidentally don't put in quite enough water, we're going to put 6 milliliters in here, but if you don't put in quite enough, of course you're going to have a lower amount of hydrogen. Now we're going to take this is all kind of the wrong way, and we're going to add the drops in, all right? So look, I'm going to be very careful. Look, 1 drop. Okay, it turned blue. Now I'll take something to stir it, and I'll go like this. Okay, make sure, yep, it looks all clear. There we go. And now we're going to do it again. That was 1 drop. Now I'm going to do another drop. Okay, now we're going to take this and stir it again. This is taking me a long time, right? There we go. There's 2 drops. Now I'll do it again. There's 3 drops. Now I'm going to stir it. Okay, there we go. Let's see, that was 3, right? Okay. There's 4 drops. Good, good. Let's stir this. There we go. That's 4. Here's 5 drops. We want to at least get to 5 because that means we're at the level required. This is 5 drops. Make sure it clears. Yes! All right, we're doing good. There's 5. Keep going. Okay, here's 6 drops. Oh, come on, you can do it. Ah! Almost there. It's not quite going. No, no. All right, that's 6 drops. So we got 0.6 milligrams per liter. Now, you would understand that we've been waiting this long, so if I tested it again, it should probably be lower than 0.6 milligrams per liter because the gas is still coming out. But I'm here to show you that it's not, because I'm going to test this more correctly. Let's scoot this to the side here. Take this one. Fill this one with 6 milliliters again. All right, again to the meniscus. Okay, perfect. Now, I'm going to go a little bit faster here. 1, 2, 3, 4, 5, 6. Uh-oh, is that going to clear? What do you think? Now, I'm just going to shake it like this. Doo, 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 doo. Oh, look at that. Clearing up, huh? We've already passed it. 6. 7, 8, should I do it? 9, whew, I don't know, I'm going to stir it. Look how gentle I'm stirring it now. I'm still trying to go fast. I just don't want to disturb the hydrogen. It's cleared. That's 9. I'll try 2 more. 1, 2. Okay, that would be 1.1 if this, that could be the end. Okay, so that if we would have added just 1, it would have cleared for sure. I added another one because I was pretty sure we could do it, and that was a titration endpoint, so that was 11 drops. That means it's 1.1 milligrams per liter. What did I say was this one? 0.6 milligrams per liter. So this was twice the concentration. And yet you would have expected that this would have been lower because I went after the fact. But because I did the testing what we call the right way, I was able to get twice the concentration. So it's very important that you do the testing correctly if that's very important to you. It's more of an art than a science. And I'm not really an artist, but here we go. Okay, so we just finished the demonstration showing that if we test the correct way by adding getting exactly 6 milliliters of water, making sure it's not less than 6 milliliters of water or more, and we take the reagent and put it in maybe a few at a time. In fact, one of the things I like to do, if I have an idea the concentration is say around 1 milligram per liter, I'll add 8, maybe even 9 drops all at once so that I have as less disturbance to the water, because every time I add a drop, that's going to disturb the hydrogen and cause more to dissipate out. Right? You'll also notice when I did the wrong way, I was stirring the water vigorously, and that's of course going to cause the hydrogen gas to escape out of the water at an exponentially faster rate. The other thing you want to consider when testing the hydrogen is when you're using a bottle or other types of devices is how long the cycle was. If it's only for 30 seconds or a minute, it's not going to have as much hydrogen because it takes time for the hydrogen gas to dissolve in the water. Just as it takes some time for the hydrogen gas to leave the water, it takes time for hydrogen gas to dissolve into the water. That's a saturation-desaturation phenomena. And so that's why you need to have probably at least 3 minutes in order to start reaching a therapeutic level. And then you want to go 6 minutes, 9 minutes. Sometimes you can even go longer depending on the bottle or the situation. But typically after around 6 to 10 minutes or so, you're going to get as high a level as the bottle is going to allow you to get. Now, the water level is also very important, because if I just put in a little bit of water, so it's only down here, on the one hand we could say, well, that's going to have more hydrogen because you're producing X amount of hydrogen in say 10 minutes, and you only have this much volume of water, and therefore that's going to have a higher level of hydrogen. But that's not true, because that hydrogen gas has to then dissolve into the water. And so actually, as we have a higher water level, then we're going to create less headspace. If there's less headspace, then the hydrogen gas will go into that headspace and then create a pressure, specifically the partial pressure of hydrogen gas, which then allows it to dissolve into the water. Because the concentration of hydrogen gas is directly proportional to the partial pressure of that gas above the water. So if you fill the water up all the way so there's no headspace at all, on the one hand, that's great because that's going to allow the highest partial pressure and therefore the highest potential concentration of hydrogen. However, you have to be very careful and cautious with these types of bottles, because by doing so, then that pressure buildup could be a little bit overwhelming to the lid, the sill, where the sill and the lid itself, as well as to the membrane and the electrode system assembly here, which that higher pressure could potentially be damaging to the bottle itself and for the longevity. It could also cause some leaking of the bottle. So you just want to get some clarification on what you need to do in general to prevent that from happening. Typically, the manufacturers and the companies are going to recommend you to fill it up to a certain level, and that's the level you want to go at. If you go much higher, you could create those problems. If you go lower than that, you're not going to have as high of hydrogen as you otherwise could have had. So all those things are going to be very important. Another point that could change the hydrogen concentration that you're measuring is what elevation you're at, the altitude that you live at. The higher the elevation, the lower the total pressure, the lower the partial pressures in general. So if you are at sea level, you're probably going to have the highest concentration of hydrogen, versus if you're living on the top of the mountain, for example, then as soon as you open the bottle, there is an increased rate of gas escaping the water, and when you actually measure the concentration of hydrogen, it's also lower. And this is just something we have noticed and experienced over time, and it makes sense based upon the partial pressures of the systems. So you sometimes actually might have to adjust. If you have a high elevation, you could actually be 0.1 to 0.3 milligrams higher if you were to adjust it to sea level. So those are also things to take into consideration.